Hey, welcome to Module 2, Transportation. In this first lecture, the first part of Module 2, we will be covering transportation modes. Transportation modes are the five most popular ones are air, which is transporting things using aircraft, rail, truck, water or ocean, that includes international freight between countries, going over seas and oceans. That also includes ferries and other stuff going over waterways like the Mississippi River in USA or the Great Lakes system in USA and Canada. And then the last one is pipeline. We sometimes transport liquids and gas long distances using pipelines. Now this lecture, a lot of it is self-evidentary, it's obvious, a lot of it you might already know, which is why you should not go over this lecture in the traditional way where you hit play, you sit back and relax and you watch the whole video. If I'm talking about something you already know or is too obvious, skip ahead 30 seconds, 1 minute, couple of minutes, because there's going to be stuff in here that you already know. This is perhaps the class in logistics that everybody teaches, but that is kind of like while I'm telling people the difference between a truck and a train, and they already know that. So this is just to make sure everybody's on the same page. I will cover some stuff that will most likely be new for you, some details about these transportation modes, but other than that, it may seem like I'm just blabbering the obvious. That said, please do go through the slides and please listen to the lecture at the slides where you feel you don't know that material. Knowing the content of this lecture is really important for exams and from real life perspective. That reminds me of a nice incident that happened when I taught this course earlier. I had a student who had an interview with a rail company in USA, one of the big 3 or 4 rail companies, and the student got a job simply because he knew some details about how rail is more environmentally friendly way to transport than trucks because they have much lower carbon emissions. And the manager interviewing him didn't know that, and he was surprised that this person knows that, and he was like, yeah, we want young people like you to market the rail services to our customers, other companies, so they can send their goods over rail. So there will be stuff that is hopefully going to be new for you, and all this stuff is useful information. So please do ensure that you do learn the content of the slides. Now I'm not going to go through every single bullet point on every single slide in this video recording. I'm only going to stop at places where I'm going to point out things which I expect that a lot of you or some of you may not know, and things I expect you already know, I'm going to skip them. You can read the slides in detail, and if you have any questions you can contact me. I think going over the slides one at a time, doing every single line on the slides would make it a little bit boring for many people. Okay. Now, why are we studying transportation? After transportation modes, we're going to go into transportation management because transportation is usually the biggest cost under logistics. So managing transportation properly is a big deal for logistics managers. Okay. So what drives transportation costs and logistics decisions? Well, the biggest factor in transportation costs is often distance. What's the distance you want to transport stuff? What drives the distance? What causes there to be a big distance or a small distance? That is your location decisions. Where is your facility located relative to your suppliers and relative to your customers is going to determine the distances, and the distances are going to determine a large part of your transportation costs. In the last module of this course, we talk a lot about location decisions. In the short term, you can kind of assume location decisions have already been done. Their locations are fixed, so distances are fixed. Given that distances are fixed, there's still a portion of transportation costs that you can manage and reduce by picking the correct mode, by picking the correct path for your goods to flow in, by picking the right quantities in which you want to ship your goods and so forth. Whatever decision you make in transportation is also going to impact your inventory costs. If you recall back to the inventory cost calculations we did, a lot of the inventory costs are driven by lead times. A portion of the lead time is transportation time. So if you pick faster transportation, your lead times will shrink, your inventory costs will shrink. If you pick slower transportation, your transportation time will be high, your lead time will be high, your inventory costs will be high. Also, the mode is going to influence your equipment, design of docks, how the warehouse works, is going to impact your customer service goals and what you expect to achieve. Now, when you do transportation, most of the time you are going to be buying a transportation service. Unless you work for a trucking company or a railroad company or an ocean freight company, you are not going to be owning ships or a lot of delivery trucks or rail cars and rail engines. So you're just going to go to a company which provides transportation service, and you're going to pay them some money to move your stuff. When you buy a transportation service, you're paying for transit time or delivery time, which is the time required to go from A or B. You're paying for reliable transportation, which is often measured in terms of, is the transit delivery time trustable or not, or are you going to say 10 days and take 15 days, and what is the risk of loss or damage? And to get these services, transit time, reliability for a certain amount of goods, you're going to pay for the service in some amount. And usually we divide the amount we pay by the distance we're going to transport something, and then again by the weight of the goods transported, so that we get a price per unit. A unit is metric ton or ton mile, metric ton per distance metric or ton mile. So if you move 1 ton or 1,000 kilograms of goods 1 mile, how much are you paying for that? You could represent it as, cent weight mile, price paid per 100 pounds moved per mile. You could represent it as kilogram per mile, something like that. Yeah, because obviously you're going to pay more the more weight you transport and the longer distance you transport. So we always represent the price per weight and per distance. Okay, we talked about the 5 modes. Let's get into it. Okay, so quick question for you to think about. Let's say we want to transport something between the point A and point B, and the distance between the points is 400 miles. So what is the fastest way we can achieve that? Will rail be fastest, or truck, or barge? Barge is like a cargo carrying boat which goes on rivers and lakes and so forth. Air, using air travel, or horse. Okay. So I recommend you pause the video, think about this for a minute, come up with your answer, and then hit play to see what the answer is. Okay, if you thought that air would be the fastest, which is a common assumption people often make, you would be not exactly true for this situation. See, air is the fastest in terms of the speed it travels, but there's a lot of setup time. You have to take goods to an airport or airfields. They have to be packed in special shaped containers that can be loaded into the cargo hold of an airplane. Then it's not door-to-door service. The airplane will land at another airport. Then you'll have to pick up the goods from that airport to take it to the destination. So if you look at the fixed time cost of air travel, there's a fixed cost up front, fixed cost at the other end. That makes it slower than truck for short distances. Usually, below 400 miles or below 500 miles, a truck can beat air. Think about it this way. You have to go from Flint to Chicago, okay, and you decide to fly. Well, you may have to go 1 hour or 2 hours before the flight time, go through security, then your plane has to land in Chicago, you have to get out of the airport and then take a taxi to wherever you want to go. It is plausible that a car or Amtrak, if it goes right next to where you want to go, might beat air travel because the distance is short. Right, so you don't have to go 2 hours early, you start driving your car, you don't have to go through security checks, you don't have to wait in queues at the airport, so all that fixed time cost is taken out, and a car might beat air travel for short distances. Same idea here. Let me show you this graph. Okay, so you can see this is air, and this is truckload, and you can see that below 500 miles the line for the truck is actually below the line for air. So truck takes less time than air for short distances, but beyond 500 miles truck takes a lot longer, air is much faster, right? So that is the point you need to keep in mind. Okay, let's look at domestic freight shipments in the US. If you look at tonnage moved, how much tons of goods were moved, okay, you can see that the highest amount of weight is moved by truck, 70%. The second one is rail, 14.8%. Multiple modes is about 4.6 or 5%. Pipeline is 5%. This will be all your fuel and natural gas usually here. This would be a lot of times rail plus truck, and could be air plus truck, right? Then we have water, 3.2%. This is only available in some areas like the Great Lakes area along the Mississippi River, things like that. And then air is less than 1%. Now if we look at the value of goods, you can see that rail moves a lot of tons, but their value is much less. Air, on the other hand, moves almost no tonnage, but moves a comparatively larger value. Trucks is about equal. In terms of dollar value of goods, they are 71%. In terms of tons, they are 70%. What this means is that expensive stuff goes by air, because it weighs less but has a lot of dollar value. Cheap stuff like coal, wood, timber, paper, cement, sand, wood, stuff like that goes by rail. There's a lot of tonnage but few dollars. And truck is everything in the middle, from very expensive to very cheap. Everything in the middle goes in trucks. Expensive things are also going by multiple modes, so about 5% by weight but 16% by value. So you might be doing air plus truck for some expensive stuff, or maybe barge plus truck or rail plus truck, but I guess mostly air plus truck, because these are expensive things compared to the weight. Okay. In terms of ton miles, the truck and rail are equal. So what does this tell us? Well, rail is carrying less weight than trucks and less dollar value than trucks, but it's moving over very long distances. When a ton is sent by rail, you're sending it to someplace really far away. Trucks are doing a lot of within state, within city deliveries as well. So in terms of tonnage, they are much more than rail, but in terms of ton miles, they're not traveling as far. Okay. So if you have to ship something across the country, you might consider rail because of its low cost. This is the price comparison. You can see air is extremely expensive by orders of magnitude. Truck is the second most expensive, and then rail and barge are the cheapest. Okay. You can see that truck is about 6, 7, or 9 times as expensive as rail and barge. Air is 4, 5, 6 times more expensive than truck. So really the differences are huge in terms of dollars per kilogram per mile moved. Obviously, if you're sending something small and light, which has a lot of dollar value, then you can choose to send it by air, like an iPhone. If you're sending something like a computer or laptop, maybe truck might be worthwhile. But if you're shipping out, lumber or something, then you have to go for the cheapest mode like rail. There are economies of scale in transportation. So you can see that if you are shipping parcels, okay, you are shipping small, each parcel is a small amount of weight, but the price per ton or ton mile is really high. Okay, with trucks you're shipping larger weight values and the price is reducing. With rail or barge you're shipping very heavy goods and the price per unit is really falling down. So that is called economies of scale in transportation. If you send bigger shipments, you're usually going to use something like rail or truck, full truckload. You're going to be in this end and have a small price per kg mile or per ton mile. If you're sending small shipments frequently, you might be sending LTL truck shipments and your price per ton mile will end up being high. So one way to reduce transportation cost is to go for economies of scale. Okay, so we compare transportation modes on some variables or dimensions. These are the popular ones: cost, speed, reliability, capability, capacity, and then there could be other ones for your situation. Okay, now on this graph, one thing we can see is how much fast or slow different modes are. Another thing you can also see is the variability, because if the points are close to the line, okay, like here truckload, you have very reliable transportation. If the points are all over the place, then sometimes it takes less time, sometimes it takes more time. Okay, so two questions. Less than truckload shipments, which are right here, they're going by truck, take a lot longer than truckload shipments. So why do you save so much time if you send a full truckload versus if you send less than a truckload? This is one of the key things you should get out of this lecture, because people intuitively understand difference between air, rail, and truck, but a lot of times people don't know what's the difference between less than truckload and truckload. They're two very different things, although they're both trucks. Okay, so let's kind of understand their differences. To understand their differences, we have to understand two terminologies. What is a line haul and what is a milk run? When you send something a long distance, let's say from city A to city B, and your truck goes from city A directly to city B, that's called a line haul movement. You're moving all the way from A to B. Okay? The key is that you move directly from A to B without intermediate pickups or deliveries. You don't stop on the way. Milk run is a collection or distribution run. So you go around in a circle collecting stuff to be shipped, or you go around in a circle delivering stuff that was already shipped. So think about the postal office. They do a milk run. The post office does a milk run, picking up mail and to be sent out and delivering mail at the same time. Okay, so milk run, you start and end at the same point, and the goal is to either pick up stuff or to deliver stuff, or to do both pickups and deliveries on the same milk run. Okay, so now we're going to see trucks, compare LTL and TL. The Trucking Association says if you have it, it moved by truck, which is pretty much true, because most things in the US move by truck. Even if things move by rail, sometimes the rail goods get transferred onto trucks at the end of the destination, because for big factories or mining operations, you might have a railroad running to the operation, but for other cases a truck goes to the train, picks it up, and does the last part of the journey. Okay. There are many small trucking companies with small fleets, few trucks. You can just buy a used truck or a truck in working condition, maybe $60,000-$70,000 or less, and start your trucking company with just one truck. And these trucking companies will often get loads here and there. Bigger companies are obviously fewer, but there's lots of bigger companies as well. Okay, so I'm going to skip some of this stuff, which I think is kind of rather obvious. The thing to remember about trucks are they have very high accessibility. They're perhaps the only mode of transportation which does door-to-door service. They can pick up from your warehouse, take it to the customer's door, take it to the door of the retail store. All other modes, air, barge, ocean freight, rail, they are usually not door to door. So they go from terminal to terminal, station to station, and then at the ends you have to use a truck. So high accessibility is the key point of trucks. They're pretty fast, the second fastest after air, and the fastest for short, small distances, but they are high cost, reliability is good. Okay. There are regulations, right? Federal guidelines allow 80,000 for the truck plus trailer combination. By the way, you should also know that what people generally call a truck is not entirely a truck, because truck is just the engine part where the driver sits, and then what's behind that is called a trailer, which carries the actual good. So the truck plus trailer combination has to weigh at most 80,000 pounds. So when they weigh a truck with the trailer, you can't go above 80,000 pounds. The truck with empty trailer is about 36,000, so the maximum load for the trailer is about 40 to 45,000 pounds. These are US regulations. Other countries have other restrictions. Now, some states allow for higher or lower weight restrictions. I believe Texas has a higher weight limit that allowed for the trailer or the combinations. You can have heavier trucks in Texas, but you can check the state level restrictions on weight. Okay, so let's get to the perhaps the most important slide in this whole lesson. What's the difference between less than truckload LTL and truckload TL? Okay. So let's do TL first. It's much easier. So one customer who buys the transportation service is going to load up the whole truck. The whole truck goes to that customer. Whether he or she uses up the whole truck or not, they pay for the whole truck. Okay. The truck will take goods directly from the consignor to the consignee, shipper to the customer or receiver. The truck is not going to do intermediate stops or deliveries. Obviously, the truck driver cannot drive 24/7, so after 11 to 14 hours of work in a day, the truck is going to stop and the driver is going to rest. But that's not an intermediate pickup or delivery. The truck driver will just stop on the route, on the side somewhere, or at a terminal maybe, but there's not going to travel all over the place picking up or distributing other stuff. Okay. This has low investment requirements in terms of a trucking company, because all you need is a truck and a driver. You don't need any collection or distribution facilities, any loading, offloading facilities. Just go to the customer loads up the truck, you go, then you go to the receiver offloads the truck, and then you just drive the truck in between. And you go straight from A to B, okay? LTL is for smaller shipments. Let's say you want to send a load which is 10,000 pounds. Why would you pay for a full truck that can carry 45,000 pounds when you only want to send 10,000 pounds worth of load, or 5,000 pounds or 3,000 pounds? So in this case, you can go for an LTL shipper, where the trucking company is going to load up more than one shipment on the same truck. Okay, so the trucking company, what they'll do is they will collect the load from you, then they will take the load, sometimes even in a small truck. They might collect the load from you in a small truck, then they'll take the load to their terminal. So multiple loads will arrive at the terminal, they will be combined into a big shipment. So let's say you're shipping something to LA. All the loads going from this region to LA will be combined into one big truck. That big truck will drive to the terminal in LA. Okay, and then at the terminal they will disaggregate the shipment into the different deliveries, and then smaller trucks or maybe the same truck will then go and do the deliveries in and around LA. So you have a milk run at the beginning to pick up the stuff, take it to the terminal, right? Okay, so we're going to have a collecting the loads part. You're going to in an LTL shipment, collect all the loads, like maybe doing a milk run, maybe using multiple small trucks. You sort the loads into destination. Now you have to load this big truck in the right order, because if this truck is going to drop off these shipments, the first address which comes up must have been loaded last, so it can be taken off first. Okay, then the full truck does the whole journey, the line haul A to B. Then at the destination, there's usually a terminal or some sort of facility where they might sort the shipments and divide them into smaller trucks or do something with them. And then you're going to go around, do a delivery milk run, and you're going to do delivery truck and make deliveries. Okay, so LTL has a lot more steps to do. And these aggregation of shipments might need to have some waiting time. So let's say your shipment goes to the LTL company's terminal today, but they're waiting for another shipment from somebody else that's going to arrive at night, and a third shipment is going to arrive tomorrow, and then maybe the day after that their truck can leave. So they have all this waiting going on where they're combining these shipments. So LTL is going to take longer, and you're going to have fewer LTL carriers, because to set up an LTL company, you need to have all this operation set up where you have terminals, you have delivery vehicles, you have collection vehicles. It's a much bigger operation, so there's fewer LTL carriers out there. There's lots of TL carriers out there. Okay. Some other information. Please read this slide. It's really important, and this one too. Okay, for the rail, let's just summarize what's the important point about rails. Rails are pretty slow moving. If you've ever been stuck on a railway crossing, you already know this, right? You already know that they're pretty slow moving. Why? Because it's more efficient in terms of fuel used up and money to make a really long train and then have it go at a slow speed, rather than make smaller trains which can go faster. Okay, most rail freight moves in full carload quantities because that's cheaper, and you're usually going to rail when you want to save money. You don't want to spend too much on transportation, but you can also do less than carload, which is going to be more expensive. Okay. Now, rails are extremely efficient ways of moving freight, 3.5 times more fuel efficient than trucks. Okay, so CSX, which is one of the big rail companies, estimates that the average fuel efficiency was 467 ton-miles per gallon of fuel. By comparison, trucks would do about 134 ton-miles per gallon. So they are about 3 to 3.5 times more fuel efficient, 75% fewer greenhouse gas emissions than trucks. So that means rails are really good. They're cheap, they're efficient, less greenhouse gas emissions. So what's the cost? Well, it's time. Transit times are long. Okay. The trains move rather slowly. Not only that they move slowly, but they spend a lot of time waiting in train terminals. Because imagine you're making this long train with maybe 100 rail cars. All 100 rail cars are not going to go to one city. So you combine the rail cars going south, then the rail stops on the way at different terminals. Some rail cars get taken off, some get added, and then it moves south. Then some rail cars have to go east, then it goes east, goes to some other railway station where cars get taken off and added. So there's all this rail cars being taken off and being added to the train operations happening at railway stations, and those operations take a long time. Imagine a train with 50 rail cars, and you have to remove the middle rail car, and then we have to add something. So so it's a long operation. So that makes the rail transport really slow. They're really flexible. You can transport lots of stuff. There's special hopper cars for grains. There are cars to move liquids. There are cooled cars to move frozen stuff. You have special cars to move automobiles, things like that. If you have an accessibility issue, there's not a railway station at your facility, or rails don't go there, or it's pretty far, often you have to combine it with trucks, but then you only pay trucks for a short part of the journey, and so you save money on the long part. Okay, let's look at air. Okay, air, the biggest advantage is really fast. The biggest con is really expensive, 50 times more expensive than rail in recent times. Reliability is high. The type of products you move by air are going to be different. You want to move expensive electronics, maybe machinery parts, which the factories stop, they need a repair. Fashion apparel, which is going to sell at a high price. Seasonal flowers, some fruits and vegetables. These things, because they have a short shelf life, so you want to move them by air because you don't want all the shelf life to be used up as they sit on a train. Now, dimensional weight, also known as dim weight, is a really important concept. Okay, the reason we air freight uses this concept is, let's say you're sending something really light, like you're sending flowers in vases or something like that, or maybe some fruit which is not very heavy. If the airline charges you per weight, you'll be paying for a small amount of weight, but your product will fill up the whole cargo space because it's not very dense. So the air company says, well, that's not useful. We can't afford to do that. So we're not going to charge you just for the weight. We're going to charge you for the volume as well. So they combine the volume and weight into what's called billable weight. So what are they going to bill you for? Okay, so they're going to bill you, there are different formulas that different companies use, but the billable weight is going to be a combination of, it's either going to be the actual weight if your product is dense and heavy, or if your product is not dense and heavy, they're going to use the dimensional weight. Okay, this is one example of a dimensional weight formula that I believe UPS uses. They do the volume, length times width times height, the volume of the package, divided by a number to get like an adjusted weight. And if your package is very light, this adjusted weight will be higher than the true weight on a scale that you measure. So your package might weigh 2 pounds on a scale, but if it's big and light, this might give it 20 pounds. So they're going to charge you for 20 pounds, not the 2 pounds. Why? Because it takes up a lot of space. And you have to pay for space as well, not just the weight. Okay, ocean again is pretty, water transportation is pretty cheap, but sometimes can be even slower than rail, especially if you think of the example of the Mississippi water system. The barges there move really, really slowly. So long transit times, low accessibility, unless you're in an area with waterways, but otherwise pretty good. Okay. For international shipments, water is the way to go. Ocean freight is the way to go for international shipments. Why? Because we have a huge infrastructure connecting ports in different countries. These large ships are very cost efficient. They are, reasonably fast, pretty fast, much faster than the vessels which go in the local waterways, and they're pretty huge. They have lots of capacity. You can look at some of the statistics of these big ships here. Let's go on. Okay. So as you saw in the Mississippi, we had barges going 5 to 10 miles per hour. These big ocean carriers in a fuel efficient mode are going to do 18.4 miles per hour or up to 30 miles per hour. They're going to go much faster. Also, these kind of run 24/7, so they don't stop. Unlike trucks or rail, they go directly from port A to port B, or sometimes they hit some small ports in a region to pick up stuff. Then they go do the line haul. But during the line haul part, they go straight and they don't stop. Okay. So self-check question for 800 miles apart, what is the fastest shipment amongst these four? Well, we know rail and water barge are really small, so it's basically between LTL and TL. And so hopefully everybody by now knows truckload truck shipments are much faster than LTL truck shipments. If you didn't know that, please go grab a cup of coffee and listen to the lecture again. Pipeline is pretty self-evident, so I'll let you read the slide. And let's go here. So this slide is really key for the exams or just general knowledge, because it summarizes pretty much everything in this lecture into one slide. So really awesome. Okay, print it out, stick it somewhere, or save it, or remember. So it tells you the strengths of each mode, tells you the limitations of each mode, tells you the primary role, what type of example products that people ship with that mode, and the primary product characteristics. So for example, truck is going to be high value finished goods, rail is going to be more raw materials because they have less value, air is going to be obviously high value finished goods, low volume, time sensitive goods, right, and so forth. And you know which one has capacity, flexibility, which one is high cost, which one is low cost, things like that. Everything that I've talked about is already summarized here. Okay? So please read this slide in detail because a lot of the MCQs on the exams tend to be based on something like this. You want to ship iPhones from here to there. What's the most appropriate mode? You want to ship lumber from here to there. What's the most appropriate mode and why? So all those sorts of questions you can kind of answer by this sort of comparison. That is it for transportation modes. Hopefully you learned something new. If you didn't learn something new, kudos, you have a lot of general knowledge about transportation. And in the next topic, we're going to start talking about how do we make transportation decisions, how do we optimize transportation costs, things like that. Now that we have a basic understanding of the different transportation modes.